everyone, welcome. Thank you for joining. I'm just going to give it probably 30 seconds to a minute for more people to join. We had pretty high registration numbers, so I want to make sure we have critical mass before we get started. As folks are joining, if you wouldn't mind putting in the chat where you're tuning in from and maybe something that you're looking forward to this fall or something you've done that you've enjoyed. I know I've really been enjoying the fall colors. Okay, looks like we have a pretty full group with us, so we can go ahead and get started. More people will kind of trickle in. So thank you everyone so much for taking some time out of your Wednesday afternoon to join us for this Weatherization Wednesday. My name is Becca Custer, and I'm a Community Engagement Manager at Efficiency Vermont and help to lead the Button Up campaign, which is Vermont's annual outreach and education campaign to really help residents and Vermonters prepare for winter. The campaign is sponsored and facilitated by Efficiency Vermont. Next slide, Bennett. For folks who might not know who Efficiency Vermont is, we are a statewide energy efficiency utility, which means that we really help reduce the cost of energy for all people living in Vermont and help folks really understand and make better use of energy and reduce their greenhouse gas emissions. And we're just one of the many partners that support the Button Up campaign. Other partners include our utilities across the state, weatherization agencies, regional planning commissions, town energy committees, and several more. So today we, of course, are talking about heat pumps, which we know is of interest to a lot of folks, and clearly that is reflective in the number of registrants we got today. So today we really hope to provide you with kind of an understanding of heat pumps, what they are, and if they might be right for your home, and some things to keep in mind if you end up moving forward with a heat pump. Leading today's presentation is my colleague, Bennett Doherty, who will be leading today's presentation, and we also have another one of our fabulous colleagues, Steve Spatz, on the call, who's going to be assisting with the Q&A. Quickly, before I do turn it over to Bennett, I do just want to run through some quick webinar logistics. So one, we are recording this webinar, and it will be posted to buttonupvermont.org and Efficiency Vermont's YouTube after the session. And I also want to note we are hosting this session again next Wednesday, October 25th at 6 p.m. and you can register for that, or let folks know who maybe could not make today's call to register at buttonupvermont.org. Next slide, Bennett. Excitingly, we are also choosing one random attendee from today's call to win a $50 gift card to a local hardware store. We'll do that drawing after the webinar, but just know if you are that lucky winner that you can expect an email from us. Lastly, after the presentation, we're going to have some time for Q&A, so encourage you, if you have questions come up, to submit them in the chat if you're joining here on Zoom, and in the comments if you're on Facebook. We'll do our best to get to as many questions as possible, but we do have a lot of folks on the call, and we also got a lot of questions submitted through registration. So kind of in an effort to address all the questions, we're really going to be trying to address question by theme to get to as many as possible. So we might not be able to get to your very specific question about your unique home situation. So highly encourage you to take advantage of the resources that Bennett's going to detail later in his presentation, including reaching out to Efficiency Vermont's customer support, signing up for a virtual home energy visit, or importantly, connecting with a contractor just to talk through your kind of specific situation. So I think with all the logistics out of the way, I'm going to turn it over to you, Bennett, to kick it off. Thanks.
Awesome. Thanks so much, Becca. And thanks for that introduction. Yeah, as Becca mentioned, my name is Bennett Doherty. I'm an engineering consultant at Efficiency Vermont. and I'm super excited to have you all joining today. So today we're gonna dive into kind of heat pumps 101 and trying to answer some questions about what are heat pumps and if they might be a right fit for your home. So let's get started kind of laying out some of the things that we want you to be able to get out of this presentation. So we're going to start out talking about heat pump fundamentals. We'll go through a little bit, or heating system fundamentals rather. We'll go through a little bit about more traditional fossil fuel systems and what those look like. And then we'll transition to what a heat pump is and how it works. And then importantly, we're going to outline the different types of heat pumps that are out there and what might be suitable based on home conditions. And then we're going to finish it off with some next steps that you can take, some questions that you might want to ask contractors if you're interested in looking for heat pumps, and finally finish with some available resources that Becca mentioned earlier for continuing that effort. So I think it would be good to start off with kind of a discussion around the fact that anytime you're looking to make changes to your heating system, it's good to start out by looking at a number of fundamental questions about why you're going for this and to have a better sense of your situation, because every home is unique. So some important questions to consider are, what are your goals? Why are you interested in doing this project or making this change? Is it because your existing heating system has failed? Or are you looking to use less fossil fuel, or are you looking to reduce your energy cost exclusively? I think getting a sense of your goals from the start is important. And then also, what are your comfort needs? Because different systems will provide different levels of comfort. Do you need every room in your house to be the same temperature? Is cooling something that's important to you? And then also, what is your house like? What's the layout of the house? Is it compact, or is it more spread out? Is it more compartmentalized, or is it more of an open floor plan? And how does that change if there's one layout on one floor versus the next floor? It's also important to ask what your distribution system is, and we'll get into more detail about that later, but kind of recognizing what is your current distribution, meaning do you have a furnace with ductwork, or do you have a boiler with piping? Because that can kind of inform what systems might be a better fit for you as well. And then importantly, how much weatherization has been done on the home. So what is the level of insulation and air sealing in the home? This presentation is mostly focused on the heat pump equipment, but we also have other presentations in this series that are dedicated to weatherization, and that can be a really important step to make the equipment I'm talking about today work even better for you. And then finally, and ultimately, this could be one of the more important questions, is what is your budget? A lot of these projects end up kind of coming down to what budget allows, and having a sense of that going in is a really good question to ask from the get-go. So to kind of get started into some more specifics, I think it's helpful to take a look at more traditional fuel-fired heating systems, which most people today in Vermont have. And it's good to understand what your system is like and what more traditional systems look like, to understand how that could transition to including heat pumps potentially. So first off are boilers. So boilers at a very simple level are meant to heat water. It could be oil, propane, natural gas, or pellets that are used as the fuel, but it's burning fuel to heat water. And then it distributes that hot water throughout the house to various spaces via circulator pumps and valves and pipes. And then that heat gets delivered to your spaces via radiators or baseboard radiators, or even heated floors. So you can see on this picture to the right, kind of the boiler itself and some of the what different radiators look like below. And finally, sometimes boilers also have the ability to provide domestic hot water heating too. So then the other big category that we typically see in traditional fuel-fired systems are furnaces. They are similar in that they are burning fuel, and again, this could be oil, propane, natural gas, it could be wood, but they are now heating air. So instead of heating water, it's heating air, and there is a blower or an air handler. There's a fan that's moving that air through ductwork throughout the house. And it arrives in the spaces via registers or grills or diffusers, as you can see on the bottom there, and that's a good indicator that you have ductwork and that you have a forced air system. And they also can include filters for filtering the air. So those are two centralized heating systems that we typically see. Another style that we see are more distributed systems, and those include space heaters like gas space heaters, which could run on propane or kerosene, and as well as wood stoves, which might be run on cordwood, or they could be pellet stoves as well. And the difference between the options before and this option was these are more point source heaters. So these are heating a specific room rather than heating a central system and delivering that throughout the rest of the home. So in summary, fuel-fired systems are all focused on delivering high temperature distribution via air or water. And when I say distribution, I'm referring to the system that brings that heat around the house. And they don't intrinsically provide cooling. And that's kind of one reason that people might turn to heat pumps, is because they do offer that cooling. And they can be subject to more volatile fuel pricing, just as we've seen like prices for oil in the past couple of years change quite a bit. And that can be a driver for people interested in making a change. And because they are combustion appliances, they also have carbon emissions directly related to them, as well as air pollutants that are a result of that combustion. So I think now transitioning the focus to presentation today is, what about heat pumps? A lot of people are talking about heat pumps, and a lot of people are interested in them. And I think goal from today is to try to understand what makes heat pumps different from those systems that I just talked about, and why it might be something that you might be interested in pursuing, and importantly, understanding the different types. So some very general heat pump characteristics. Importantly, I think it's good to clarify that heat pumps run on electricity. So that can be attractive for those that are interested in moving away from fossil fuels, in that that's kind of what you hear, electrification. That's an avenue towards more efficient electric heating. They also can provide cooling, as I mentioned. So a lot of times people find themselves interested in heat pumps when they want to add cooling to a home that doesn't have it. And this can be a great avenue to do that. And then finally, the reason why people are so excited about heat pumps as opposed to electric resistance heating is that they are much more efficient. So they can be 2 to 4 times more efficient than electric resistance heating. And that kind of ties into the opportunities for cost savings in their operation as well. So as we talk about heat pumps, and for this presentation, I thought it would be a good idea to get a sense of how they work at a very high level too, because I think that can be informative to understand what makes them unique from electric resistance, for example, or the other systems we talked about. So as I said, they run on electricity, but what makes them different is that they are using refrigerants to move or pump heat from one space to another. And I think it's helpful to start thinking about them with the example of traditional air conditioning units, which have been around for a long time. And in those cases, an air conditioning unit, this is kind of a simple diagram here to show 4 main components, with a compressor, an expansion valve, a condenser, and an evaporator. And though you don't need to dive into the details of those terms necessarily, but it's good to be familiar with them as you're learning more about heat pumps. And in the example of an AC unit, of an air conditioning unit, we can start in the bottom right of the diagram and look at, there's cold liquid refrigerant that's entering the building, and that's being used to cool down the space. So heat from the house is getting absorbed into that cold refrigerant, and as it moves through the coil, it heats up a little bit. And then that refrigerant gets pumped into a compressor, and the compressor is raising the pressure of the refrigerant while it's maintaining the same volume, which means that the temperature of the refrigerant is getting increased. So what this allows us to do is have a very high temperature refrigerant on the outside. And even if it's really hot outside, like let's say it's a 90-degree summer day, that refrigerant temperature is going to be even higher. And what that means is when you have something hotter than the surrounding area, it's going to reject heat to the surrounding space. So that's then kind of rejecting that energy that was in the home to the outside. And then finally, it goes down through the expansion valve, and it's allowed to expand, fall to a lower temperature, and at lower pressure, and at that lower pressure, it's also a lower temperature, enters the house, and it can start extracting heat from the house again. So that's kind of the basic cycle that we see with heat pumps. And the advantage is that instead of like having just using electric resistance for heating, in this case, I guess I'm talking about cooling, but we're using the electricity to run the compressor. So the smart thing that somebody came up with is, well, what if we reverse this cycle? So now let's say that it's cold outside and we want to heat the inside space. We're using the exact same technology that we find in AC units, but we're reversing the cycle. So now we are taking that heat from the outside, even when it's very cold out. There's still heat to be gathered, and we are moving it into the inside space. And so I think importantly, this can look like a lot of different forms. There are different types of outdoor units out there. There's different types of indoor units, but fundamentally, this is the same technology that you'll find in all heat pump units. So here I just show a couple little diagrams of what these different outdoor units could look like. Typically, the most common ones we see are air source, meaning they're pulling energy from that air. But there are also ground source units as well. So that means that they're pulling that energy rather than from the air, they're pulling it from the ground or in some cases from outdoor water. And then the next aspect of it is what is the indoor distribution system, or what is the indoor unit? And so just a couple diagrams, it could look like a heat pump head, which is probably what most people think of. But it could also be a ducted unit providing heat to the space via ductwork, or there are also ones that provide it via hydronic distribution or water. So there's different combinations of outdoor units and indoor units, and we're going to talk through some of those different combinations today. But I think it's helpful to have a fundamental understanding of how they work and why they are operating more efficiently, because they're taking advantage of that, the phase change properties of refrigerants. So I think it's also important to establish that heat pumps have come a long way in the last couple of years in particular, and are able to heat to very much lower temperatures than they used to be able to. So even in the cold winters in Vermont, you can have a well-designed heat pump system that can heat well below zero. And the key to look out for this is that you're looking for cold climate heat pumps that are specifically designed to operate in cold climates. Most of contractors are in the state are selling those units today. And each manufacturer has different specifications as far as what their capacity outputs can be at different temperatures, what their efficiencies are. And I encourage you to look into that as you start to kind of pick out as you get specified for different heat pumps. But critically ensuring that you buy that cold climate unit would be the most important aspect. And it also heavily depends on the home, whether your home will be able to be exclusively run on heat pumps in kind of newer, more energy efficient homes with really strong thermal envelopes. There are plenty of examples of heat pumps being the sole heating source, and in many older homes that don't have as high levels of insulation, typically you'll have some sort of supplemental heat that helps support during those coldest times. So establishing that how they work and what that they do work, I think the next question is, which one is right for you? What kinds of systems are out there? Today we're gonna talk through 4 main systems and try to demonstrate how they're different and what they might be applied for. So let's talk about these in a little bit more detail. So starting with ductless heat pumps. Ductless heat pumps are the most common unit, what we see in most homes, and I think what people most often think of when they refer to heat pumps. So there's an outdoor unit and an indoor head, and you can see in this picture that head might be mounted on the wall. There are also some different names that get tossed around for these. So we're calling them ductless heat pumps here. You might also hear mini split heat pumps is a common terminology. You might also hear other names like one-to-one or split heat pumps or multi-zone heat pumps. There's a lot of different terms, but this is the most common one. And the key to understand about these is that they are delivering heat into specific single spaces. So wherever that indoor head is located, it's delivering heat into that space. And typically, homes would require more than one of these heads in order to heat an entire home. And so these are more kind of akin to what we talked about before, where we had those like wood stoves or electric space heaters or gas space heaters. You can kind of think of these in the same category in that they are heating a specific space, but they're delivering it in a much different way. So showing some pictures of what these look like. A lot of people have probably seen these around. So there are these are the outdoor units. There's two main different types. There are single zone units, single zone setups, and multi-zone setups. So on the left picture here, we have 4 different single zone units, and the way that those work is it means that there's one outdoor unit tied to one indoor unit. And so those are delivering, that refrigerant line is directly just tied to that single indoor head. Whereas the multi-split unit we see on to the right here is a larger unit that has multiple heads tied into it. And both systems can work great. In general, we do see that the single zone systems can operate more efficiently than the multi-zone systems. It's worth having that conversation with a contractor if you're interested in these and want to compare differences between those to ask what it might look like to do it with single zone units versus multi-zone units. So then looking at the indoor units, so as I mentioned before, that one on the left is the kind of most commonly thought of wall hung unit. But they do come in different shapes and it's different from every manufacturer. But there are also floor mounted units that you can see on the top right here if a wall mounted unit isn't right for you. And then they also have these ceiling recessed units that can go into the ceiling and kind of be a little bit more hidden. I guess some people don't love the look of them, so they try to find ways to more conceal these units. They all work similarly, and they also have filters in them that I think it's important to call it. It's good to clean regularly. If you do have a heat pump, there's a filter in the front that you can pull out and vacuum or clean off, and it's intended for a homeowner to do that. Aside from that, you can also do more thorough cleaning done by a professional cleaner, which is helpful to over time maintain the system and keep it working properly. So just highlighting some points about ductless heat pumps. They generally speaking are the least expensive option of the ones that we're talking about today. It depends on how many you're planning on installing, but it also is an avenue for kind of taking one chunk of the heating task at a time. They are relatively fast to install, and they are also are versatile in different types of homes because of the first two options, really, that they kind of can fit into different spaces depending on your needs. And all of that continues into the fact that they are useful for partial fuel switching, meaning you may not necessarily be looking to replace your entire heating system, but you're looking to offset some of the fuel that you use now, or you may be looking to do that and add some cooling to spaces. And so what's nice about these is they can be used to help with part of that load, especially in the shoulder seasons, or target certain areas in the home. So you don't need to fully change out your entire heating system to go with them. That being said, if you are interested in trying to completely change your heating system and go with these units, typically weatherization is an important aspect to consider here. To get the most out of these units, you typically have to improve the air sealing and insulation in the home, so that your home can be kind of buttoned up, I guess we could say, for the output that these ductless units put out. So they also do, because they are more of a distributed option, they do require a little bit more tolerance for temperature variation. So you're not delivering the same temperature to every room. It is dependent on where these heat pumps are located. And as I mentioned before, they are typically more visibly prominent, and that pushes people away from them in some cases. And where do they work well? So as I mentioned before, they compare really well with weatherization projects, and there are contractors out there that do both of these things together that will help weatherize your home and install heat pumps. And that's an option that a lot of people like doing together. They're good for homes with simple layouts, with open floor plans and few bedrooms. That's where it's most straightforward to figure out how to install it and what the layout should be. That being said, if you do have multiple rooms, it doesn't mean that you're not a good candidate for it. It just makes the design a little bit more complicated. And also, homes with existing wood heating or zone central heating can be beneficial for these ductless units, because then you're able to more easily control what spaces are served by the existing system and what spaces you want to be served by the heat pumps that you put in these ductless units. And as I mentioned before, they are also great for adding heating or cooling to a particular room. If there's a certain space that you doesn't currently have heating, or it gets really hot and you want to keep it cool, these are a great option for that. All right, so we just talked about ductless units, and now I want to transition to ducted heat pumps. So ducted heat pumps are more of a central approach in general, that can use ductwork to distribute the warm air to the rest of the home. So ductless heat pumps are similar in that they have an outdoor unit that is pulling energy from the outdoor space, and then it's putting that energy, that heat, into a indoor unit. But the difference is that indoor unit, instead of being directly in the space, it is connected to ductwork. It has a blower and an air handler built in, and it's blowing that warm air throughout the house. Importantly, they can also do cooling as well. So that's a way to provide central AC, is through a ducted heat pump. And there are two types to distinguish between. I kind of mentioned the central ones, where you might have a single system in the basement, for example. But they also make compact ducted units, and that's what I have shown on the bottom here. And the idea behind those is that if you have multiple rooms that you would like to heat, but you don't have the ability to run ductwork throughout the entire house, but you may be able to run it just to those specific rooms, those are a great option. Sometimes like bedrooms upstairs can be a potential use case for these, where they're just more compact, smaller. They're not putting out the same amount of heat that a central system might do, but it's intended for just supplying to a handful of rooms. So ducted heat pumps can sometimes take advantage of existing ductwork, which is great. They also include inline air filters, and as I mentioned before, they can be helpful for reaching smaller rooms. That said, they are typically more expensive than ductless units if you're doing kind of one for one, but it does depend on what the home needs in order to make that actual comparison. And in many cases, the existing ducts do need to be altered. So if you're in a situation, and this is something that you talk with your contractor about, if you're in a situation where you don't need to make that altering, that's great, but oftentimes some work needs to be done. And of course, they're not suited for homes that don't have the ability to have ducts. So where do they work well? I would say that homes with unfinished basements that have space for air handlers and ductwork to be added in. So the example here is a single-story ranch that might have an unfinished basement. There might be space to more easily do that renovation. But in general, these can pair well with more robust interior renovation if interior ductwork needs to be changed or altered. And in cases where you're hoping to reach many small rooms and there are ability to do that via ductwork, then this could be a good example, good option. So we just talked about ductless and ducted heat pumps, and those are both pulling energy from the air. And this is an air to water heat pump, and it's doing the same thing. This is a little bit of a newer technology to the US and to the Vermont market. It's something that's been established in other countries for a long time now. But the idea behind these is, instead of bringing energy from the outside and putting it into warm air like the other units we just talked about, this is putting it into warm water. So this is also similarly a central heat pump, but it's more targeting water. And I think one important thing to clarify is these are distinct from heat pump water heaters, which heat pump water heaters are focused on providing domestic hot water heating. And these units and all the units that I'm talking about today are focused on providing space heating. So air to water heat pumps are a whole house system, and they're most often used with hydronic distribution, again, meaning you have a radiant system. And it's a good option for those that are interested in low temperature radiant heating. And I think that's an important clarification to make there. A lot of people will ask if they can kind of just swap in their existing boiler for an air to water heat pump. And typically it's not quite that simple, because more often than not, existing boilers will be providing very hot water, like let's say in the range of 160 to 180 degrees, whereas a air to water heat pump will be producing lower temperature water somewhere in the range of 110 to 120 degrees. And so what that means is that you ultimately have a different design. So the example, this picture on the top here is a low temperature emitter. So that's a radiator that has larger surface area to handle these lower temperatures. And then the bottom is the kind of layment out for a underfloor radiant system. So just showing a couple pictures here, examples of an air to water system. The outdoor unit, that can look very similar to the units we saw before. The difference being that it's the indoor unit, what it's doing is converting that energy into water. Oftentimes there's a buffer tank included there as well. And because you are typically sending that water to multiple rooms, you have some more involved piping in order to serve all those spaces. Air to water heat pumps, as I said, can be thought of as whole house systems, and they also do have the potential for providing domestic hot water. Depends on the design there. So these are a little bit more complicated systems that are good to really work with your contractor on designing. And depending on the home, you may be able to use the existing distribution infrastructure, but it's not typically plug and play with existing radiators. Oftentimes the radiators need to be changed, and sometimes this can be an expensive job. So that's something to ask the contractor too. And if cooling is desired, then ductwork is typically the avenue in order to get cooling into the space. And I would say that where these work well are homes that already have low temperature emitters, such as radiant flooring or specialized radiators. Also homes that have appropriately zoned distribution. So if you have multiple zones already for your radiant distribution, that can be a big plus to making these work well. And these are central systems. So they're typically included in kind of larger retrofits at where there's a larger budget available for doing more work. So finally, the fourth system that I wanted to discuss are ground source heat pumps. And ground source heat pumps, there's different names, but generally speaking, they're also referred to as geothermal heat pumps. I think ground source heat pumps are good to consider as a very efficient heating option. It is also generally kind of a more expensive option as well. So what's great about ground source heat pumps is that they take advantage of the stable temperatures of the earth or the water where they're pulling their heat from. So the earth will maintain a much more stable temperature throughout the year than the outdoor air is. So that can allow for higher efficiencies with these units. And the layout for them includes, there's outdoor infrastructure, some setup for how you're pulling that energy from the ground, and then a pump to pump that water the water glycol mix in this case. There's a heat pump unit and the indoor distribution infrastructure inside, and that indoor distribution can be forced air or hydronic distribution systems, and it again would be designed for that lower temperature, similar to what we talked about with air to water heat pumps. And just quickly, there are different types of ground source heat pumps. Here's just two examples. Oftentimes they are vertical boreholes that are drilled into the ground, kind of like a well, and you're running lines down that way and pulling energy from the ground that way. You can also have open loop systems too, that are pulling that energy from the water. Not pictured here are some other options where you could have a horizontal layout, or you could have even people work on having them laid out in ponds or in nearby lakes. Generally speaking, the closed loop options are kind of the most straightforward, but with all of this, there's a lot of engineering that's involved to get it right. So when that's all done well, when you have somebody and you have a good case for it, you can operate with very high efficiency when that design is done properly, and that's one of the big benefits that people see with them. The other nice thing is that it can provide that consistent temperature for both heating and cooling all year. And if there's existing low temperature distribution, then it could be possible for a retrofit. But generally, these are big projects. Typically, they are kind of one of the most expensive whole house options, and they can require significant drilling or excavation, and it depends a lot on the specific site conditions. So it's more of a bit of a more challenging process, but something that you have to assess with a contractor what would be possible at your site. And as I said, it requires more detailed design. So I think where do these systems work well? I would say generally they do scale better in larger homes that are ready for a significant heating retrofit, and that also generally have a higher budget available. The homes that are kind of have the site conditions that are appropriate for drilling and excavation, that's a critical factor to be able to even consider them upfront. And as I mentioned before, if you're doing radiant distribution here, where the difference between an existing boiler would be that we're working with low temperature distribution. So just presented a bunch of different types, and I think it can be helpful to try to provide a little bit of a summary of the 4 different types that we talked about. So we went through ductless, ducted, air to water, and ground source heat pumps. They have different system types, right? So the ductless we mentioned are more of a decentralized approach, whereas the air to water and ground source systems are more of a central approach to a whole house heating and cooling. And the distribution infrastructure can be different. So with ductless, as we said, it's decentralized. There's not actual distribution infrastructure. With ducted, you're having ductwork running through the house. With air to water and ground source, it's typically hydronic, and you can also work on having ducts input for cooling as well. And as I kind of talked throughout, there's a different complexity with each of these. I think this is just me making up a rough idea of how they compare to each other. Really, is that ductless units are the most popular because they are the least complex, and a lot of contractors are readily available to do them. But as you get to the more complicated systems, they are generally more expensive. I will mention that there are larger rebates available for them because of that. But they are more expensive, and there are fewer contractors that are available to do those systems. So I think if you're looking to do a larger project with an air to water heat pump or a ground source heat pump, more patience is needed to get the right contractor and get the design figured out appropriately. So we just talked about a bunch of different technologies, and I think there's a couple things that I just would like everybody to try to walk away from. I think circling back to the place we started was these questions that kind of drive your initial thoughts about what are you looking to get out of these systems, because there's a bunch of different options, and I think by outlining what you're looking for in the beginning, that can help help the conversations with contractors from the get-go, and kind of help guide you towards the systems that are more fit for your home and your goals. The other thing that I'd like to mention here is it can also be very helpful to go through these questions, even if you're not necessarily thinking about making this change right now. I think a lot of people are interested in doing something with their heating system different. They maybe want to have a more comfortable heating system, or it's not working well for them, but it works fine for now, so they don't pay too much attention to it. And then all of a sudden it fails. And if it's in the winter, let's say, then you're kind of stuck, and it's much harder to replace your heating system with something that you're looking forward to. And oftentimes people are kind of hurried to replace with whatever was there before. So if you're hoping to make a change in the future, I think, and you're tuning in now, it's great to start that conversation now and try to get a sense of what contractors are out there, what technologies are out there, and what might be a good fit. So you have a little bit of a plan in place moving forward. And those are all questions that happy to, if you call into our customer support line, we can talk through that as well. So a couple of different questions to take away that you can ask your contractor. So first up, we mentioned how many different heat pumps are out there. What types of heat pumps do you install? Get a sense of what they regularly do so you know what's on the table as you're talking to them. Do you bundle heat pumps with weatherization work? I mentioned the importance of weatherization in this effort, and some contractors have nice programs built together where they can do both the weatherization and the heat pump install as well. How will you determine the heating loads and sizing for the system? This isn't something that we talked about too much in this presentation, but I think that's a good question to ask the contractor, especially if you're looking towards some of the bigger central systems, asking them and narrowing down what their sizing and design strategies are, so you can feel confident in the system that you'll be getting. And then finally, talked a lot about different distribution infrastructure. And so I think answering the question of, I want to switch to a different system, but can I use my existing infrastructure, or will it require a big change to that as well? Because that can inform those decisions quite a bit. So if you're interested in heat pumps, I think a good place to get started, you can always contact us, our customer support team, for technical questions, and you can also sign up for virtual home energy visits. You can find those on the Efficiency Vermont website. You can also look for contractors that do heat pump installations by going to the efficiencyvermont.com/pro link, where you can find Efficiency Excellence Network contractors that are vetted by Efficiency Vermont, and they list the services that they provide. So that can be a way to search for contractors in your area that do heat pump installations. And finally, I think it's important to also check out the rebates that are available from Efficiency Vermont and your utility. A lot of the systems I talked about today do have rebates available, so you can check those out at the link below. And for anybody that was impacted by the floods this summer, there are also additional rebates available for eligible flood impacted customers. So please follow up and check out the flood rebate page if that pertains to you. And finally, if you are interested in financing options for this, for these projects, there are a couple different avenues towards that. We do have a home energy loan that has financing for up to $20,000 with low and no interest loans. And the eligible projects for that include heat pumps. It can include Energy Star appliances, weatherization work. That's a great program for financing. And then the weatherization repayment assistance program is another avenue to defer some of the payments for projects like these onto your monthly utility bill. Those are focused on weatherization, but heat pumps can be included in that financing too. So if you're interested in those options, please check out the efficiencyvermont.com/financing page. Awesome. So I'll leave it there. Just want to say thank you so much for listening and tuning in. I'm going to go ahead and pass it off to Steve now, who's going to do kind of the question and answer portion. And yeah, I just want to say thanks for taking the time to listen to this presentation and your curiosity about this. So Steve, if you're available, I'll go ahead and pass it off to you for the questions and answers.
All right, thank you, Bennett. and been communicating with many of you here in the chat as well. So thank you for all the questions as they have come through. What I think I'll do now here is to take a few minutes to summarize kind of the themes around some of the questions that we've gotten here today from the chat that were submitted to us prior to the session today, and just general, themes around heat pumps in general. So Bennett really covered, I think, a good chunk of that, of what the considerations are for expectations around heat pumps. They can be one of the things that came out of the chat was different applications. They can be anything and everything, or they can be a small part of the equation. It really does depend on what you're aiming to do with the heat pump, what your expectations are around it, what the existing conditions of the home are, and how you want to integrate it. Certainly, it is totally achievable to be designing and retrofitting homes to be heat pumps only, to only be relying on heat pumps. But it's also, the common installation that we see is heat pumps being integrated into existing systems of existing homes, either physically integrated to the function of the whole house system, or as standalone heat pumps to supplement what's already there. So there's a variety of different ways you can utilize heat pumps in the home. But if we get into some of the specifics around, the installation requirements, sizing of units is really going to be dependent on what you're trying to do with the heat pump, whether it's going to be heating one space or the whole house. It really comes down to actually doing appropriate design load calculations for the house and or space. And that is something that the contractor and or the distributor is going to do to define what size heat pump you need for the use at hand. So that is a basis of design for any heat pump system, or any heating or cooling system in general, whether it's fossil fuel or heat pumps. Placement of the equipment, inside the house, if you're talking wall units, typically they're installed on an outside wall because that makes for the easiest installation of the line sets connecting the indoor unit to the outdoor unit. But they can be used on interior walls as well, as long as accommodations are made for piping of everything that needs to be piped and condensation. Outdoor equipment needs to be sited appropriately to have setbacks from venting from existing heating and cooling equipment from the home, as well as fuel tanks outside, and also keeping the heat pump equipment out of the elements. You don't want to be putting one directly under the drip line of a roof that's going to be running a lot of water, snow, or ice off of the roof or into the unit. So keeping clear access to the refrigerant coil so that it can do what it's supposed to do and air can move freely through it. We had questions about different brands of heat pumps. There really is not a difference, and what you'll end up finding is most contractors prefer a certain brand because of their experience with the manufacturer and with the distributor and their familiarity with the equipment. So as Bennett noted, cold climate rated heat pumps is what we're talking about here as far as its performance and fit for our climate. And they essentially all use the same type of equipment components in their heat pumps to provide for this purpose and this level of performance. Heat pumps have been evolving over years, and the way that the refrigerant is moved through its cycle to capture heat energy from the ambient air is what has allowed the heat pumps to be better performing in cold climates. There are some advances coming down the road with different refrigerant types as well, which will impact the performance of the heat pumps, make them be able to do higher heating output at lower ambient outdoor temperatures. But as we've noted here, these heat pumps will still be generating heat at 20 plus below zero temperatures outside. Output does drop as the ambient temperature drops. But we see very few hours over an entire heating season that gets that cold. So there's really only, a handful of hours in any heating season where the heat pump's going to be stretched for capacity because of those low outdoor temperatures. And, once the sun rises and the temperature rebounds, quote unquote, to -5 or 0 degrees or 5 above, you still have a very high efficiency heating system at that point with good capacity. So that's with what we have for current technology and equipment. New refrigerant technology, again, will shift that dynamic a little bit, but it will be a longer on-ramp before we see that new refrigerant technology really take over what's currently available. installation of the indoor equipment, you know, you really have to picture a ductless wall unit as a space heater. And so what it has access to, what it sees in the space is the space it's going to condition. So locating the indoor unit in the most advantageous part of the room to move the heat, because it's being blown, you know, you're moving air across a hot refrigerant coil, and that's what's heating the space or cooling the space. So the more access and reach that unit has on the wall, the better the impact to the space for keeping it comfortable. We talked about existing distribution and how to utilize that. You know, heat pump equipment is a, you know, as Bennett noted, a low temperature distribution type heating appliance. So it does not put out the same density of BTUs, higher heat that fossil fuel equipment does. So that really needs to be factored into what type of distribution system you're integrating the heat pump into. If you're building a new home or installing new distribution in a home, or significantly modifying the distribution of an existing home, you really can start to fine-tune that distribution system to utilize the heat pump most effectively and totally rely on the heat pump if you'd like. But in many existing homes, existing ducted systems, you may be able to use the heat pump as is with that ducted system, but not rely on it completely. You may have to make some modifications to the ducted system. When we're talking about hydronic heating, if you have baseboard hot water heating, radiators, those are hydronic distribution types that often will need modification to work with an air to water or a geothermal heat pump. If you have radiant floors, those can be more readily modified to work with air to water or geothermal heat pump systems, because it's a better match for the temperatures to be generated by the heat pumps. An air to water or geothermal heating system is going to be storing heat energy in a thermal storage tank, and that's what's being used for distribution within the home. So you do have some redundancy in that storage tank for the distribution side of the equation as well. So interaction with existing heating systems is another theme that we had. As we were saying here, you know, oftentimes you're going to need to still retain the existing heating system that is in the home if you're adding heat pumps to the home. And where you decide to rely on that existing system really comes back to your choice of what you want to get out of the heat pumps. If you're only putting one heat pump in one space in your house to try to make that space more comfortable, then you're probably going to still rely pretty closely to your existing fossil fuel system to keep the whole house comfortable. If you're putting in multiple heat pumps and you'd like to really shift your equation off of the fossil fuel use, then you can start to dial in, you know, your switchover points of when you want to rely on the heat pump and when you want to get back to using the fossil fuel equipment. You can do that manually, or there's a lot of products and equipment on the market that integrates the function of the heat pump directly with the existing furnace or boiler that can control that switchover point. That can be based on an outdoor temperature, that can be based on the indoor temperature set point, it can be based on a variety of different things. So there's no either or if therefore but sort of scenarios with heat pumps. It really is a matter of what you want to get out of it, what you're trying to achieve by using them with an existing system and an existing home. There are calculators and tools to use to determine switchover points, and that can be, again, based on savings, you know, financial savings. It can be based on just a set outdoor temperature or indoor temperature. And it can be also, you know, the big factor in the room here is the comfort. You want to be that cozy little bear in the corner, you know, that is behind me right now, behind Bennett. It really, you know, it comes back to being comfortable in the home and what you're willing to pay for to get that comfort. Financial resources. So there's questions about the Inflation Reduction Act. That is a federal funding opportunity that is still working through its process, both at the federal and state level. That program is not yet available here in Vermont or in any state at this point. So we are still tracking that. Don't expect to see anything for that to be implemented until sometime next year in 2024. There are tax credits for heat pumps that are available now that you can determine if you're eligible for by working with a tax preparer or on your own. There were questions about ownership or lease options or free options with heat pumps. There really aren't any programs for free or lease options. It's really, purchasing a heat pump to have it installed. How current rebates and incentives show up with heat pumps is the rebates available from your electric utility and from Efficiency Vermont are channeled through the distributors that are participating in our heat pump programs here in Vermont. So that means when an installer purchases a heat pump from one of the participating distributors, such as FW Webs, Granite Group, Blodgett Supply, et cetera, they are receiving a point of sale discount that applies the utility and Efficiency Vermont rebates to the cost of the equipment purchased through the distributor. There are also some other enhancements or additional money available for households depending on your household income that can be applied for directly to the utilities. So that's how those show up for ductless and ducted heat pumps. We do have incentive and rebate programs available for geothermal and air to water heat pumps. Those are rebates that are available through the installer. So you do need to work with an Efficiency Vermont EEN installer to gain access to those rebates or incentives. So those can be accessed through our Efficiency Vermont EEN contractor list. There are a lot of questions on operational cost and savings, and we're not trying to avoid committing to something by saying that's not something that we can really answer here, but it really is so situationally specific to the house, to the user, to the conditions, to the expectations. So there really are so many variables that do go into that. When we're just looking at the raw efficiency, quote unquote, of the equipment compared to the efficiency of the other heat generating options available, fossil fuel options, wood or pellet or biomass options, there really is no arguing with the tested data of what the efficiency is of the heat pump equipment comparatively to any of those other types of heating system types. So on a equipment basis, heat pumps are more efficient to generate and provide the heat than another option may be. How it gets used and how it's integrated with what the existing systems are in the home and what your expectations are from it really give you the full equation of what type of savings you're going to see and how it will impact your overall energy costs. Last couple things here. I know there are a lot of specifics around specific uses or installations in people's homes. Again, you should work with an installer for defining how those or what your considerations are and what you want to get out of the heat pump. But there's really no limit to how they can be used depending on what you want to do with them in a home or a building. Maintenance is required. Monthly to bi-monthly maintenance on the indoor unit itself, cleaning the filters in it because you are moving air, so you will get dirt and contaminants that will be captured by the air filter on the indoor unit that needs regular cleaning. The outdoor unit does require maintenance as well, annually, biannually. So it just needs to be maintained like any other appliance in the home. And if with proper maintenance, heat pumps can last for decades. I've seen equipment that's 20 plus years old still working in buildings that's been maintained over time. So we are coming up on time, and that's as much as I'm going to cover through for you for questions here today. But Efficiency Vermont is here for you as a resource. If you want to get deeper into your specifics to questions you have on your home, you can reach out to us, and our customer support team is excellent at answering all of those questions for you. We can help facilitate you getting in touch with a contractor to answer more specific questions for you as well. So thanks for your time today, and appreciate you joining us.
I'll just say one last thing. Yes, again, thank you so much, everyone, for joining today, and especially want to thank Steve and Bennett for their expertise. You'll get an email since you registered for today's session with the recording, the slides, and hopefully some form of the chat so you can see all the great answers that Steve put in the chat. So again, thank you so much, everyone, for joining, and have a great rest of your afternoon.
Take care.
Thank you.